Welcome back, everyone. We're going to be looking at congruent triangles today, and we're going to have some new vocabulary: congruent polygons, and corresponding parts. So in this lesson, we are going to match up sides to their same side, but in a different triangle. So press pause, take down these notes, and then I'll just read over it with you. Congruent. Two congruent figures are shapes that have exactly the same size and shape. Congruent polygons, all of the parts of one polygon are congruent to the matching parts of another polygon. Corresponding parts, what that means is matching parts. Corresponding includes corresponding angles and sides. So we have an example here of a congruent polygon. In this case, we're talking about triangles. So words, the two polygons are congruent if and only if they're corresponding parts. So when they say corresponding parts, they mean all sides and all angles. So if you take a look at this picture, sometimes it's helpful to do some color coding here. So you'll notice that if we looked at B and J here, well, in the diagram they're marked with these we call them like ticks, or they're just referring to that specific angle. Because they have the same markings, they're congruent. Similarly, if you look at H, for example, H has two tick marks and A has two tick marks, therefore those angles are congruent. If you look at C, well, it has three of them, therefore it corresponds to this one with three there as well. The same thing's true of the sides, so we notice that if we have this side over here with one, that's the same or corresponding to that one in that triangle. So the two sides here will match with these two sides here, and lastly, these with the three will match with these here. So a congruence statement is what you say when you have proven that each side and each angle are congruent. We say that the triangle this time, notice that they're showing you here specifically that the letters have to be in a correct order, which means if the red goes to the A and the H, that needs to show up in the answer as well. So we'll go through some here and just practice. So it says, show that the polygons are congruent, including all corresponding parts, and then write a congruence statement. So let's see, we need to maybe identify, we'll start with the small side. So that's just a good strategy to start with. We'll say, okay, look for the small. Well, it's kind of hard to tell exactly. We'll just say this side here. That side looks like it maybe goes with this side. And in this case, it's nice because the shapes they kind of have the same orientation. So that might make it a little bit easier. Here, this side seems to kind of go with this side. And this side kind of goes with this side. The bottom kind of goes with this side. And then we have the last one, RT. So in this case, we need to say that they are congruent. So first of all, we are going to state the segments that are congruent. So let's use the yellow one first. So we could say AE is congruent to RQ. Notice here that the order matters. So if I start at the R, I got to start at the A. If I would have written that in reverse, it would be incorrect. So let's do from A to B. That is congruent to R to T. That's the green part. Then we keep going, so let's do B to C. That is congruent to T, P. And again, order matters. So we'll go on to the next one. We have C, D is congruent to P, S. And we would have that SQ is congruent to DE. See how many we have here. We might need one, 2, 3, 4, 5. So we need to have 5 congruence statements. One thing to note though, if you went in the reverse order, let's take this one for example. If you said ED is congruent to QS, that's the same, that's okay. What you cannot do is ED and then say SQ, because the order isn't the same. You're going in this direction and then you're going in this direction. So this one I'd like you to think about on your own. Press pause and we'll go over it. Okay, so one thing to note here, one good strategy would be to take these in order. So from A to B has to correspond to D to E. From B to C has to correspond to E to F. And then finally, we could go from C to A. In that case, in this triangle, it would be from F to D. So when I went ahead and did some color encoding, I made sure that I was looking at the congruent parts. So this guy right here, they were that turquoise color. From B to C was kind of this color here. And from C to A was this dark bluish color. So these would be the congruent statements. So you would go ahead and state that they are congruent. So AB is congruent to DE, and their segments. So we would say BG is congruent to EF, and CA is congruent to FD. All right, so the next thing is we are going to use these strategies to come up with, use them to solve equations. So in this case, it's given that the triangles are congruent. So I'm going to press pause. I want you to see if you could identify the corresponding parts. All right, so here I just kind of have a strategy of looking for the pairs when they're written in order. So here I took the first pair at that one, here I took the second pair, and then I just took the first and the last, okay? And then I color-coded that. So we're going to use this to solve an equation. So let's take a look at what we know. Well, it looks like the two, which I'll call like burgundy ones, I have two variables here, so I can't start with that one. So I'm going to have to start with this green one. I was thinking I was talking about the side, but it's actually talking about this angle. So we would get 6y minus 14 is actually equal to this angle inside of here. So if we add 14 and then we would get equals 54, divide both sides by 6, and we get that y is equal to 9. So that helps me in the other part, because now I know that this here number is just 9, so I can replace this times, and that is going to be equal to 7.5. So we would get x minus 18 is equal to 7.5. Add 18 to both sides, and we get x is equal to 25.5. So just another example here. Take a minute, see if you can kind of figure it out. Okay, so I just did some diagramming. Now we want to go through and see if we can figure out our missing variables. So one thing I notice here is the orange side, that has only one variable. So that is going to be helpful to be able to solve this equation. So if 2y minus 3 is equal to 2.5, well, I just need to add 3 to both sides, and I get 2y is equal to 5.5, and divide both sides by 2, and we get y is equal to 2.75. All right, well then let's look at the next one. So this looks like it's telling me about an angle. So notice here that it's talking about this angle, and we know that if this is true, that the angle between the orange and the purple is going to be the same as the orange and the purple here. And between the blue and the purple is going to be the same as the blue and the purple here. So we can say 6x plus 8 equals 35. Solve for x, and we get 6x is equal to 27. Divide both sides by 6, and we get that x equals 4.5.